Assalamualaikum and greetings. We are from Group 5 M3 CDCS 23048. It's going to present about inset classification using segmentation and enhancement. With our presentations, I'm going to introduce our team members. This is Umi Fatiha binti Jeffrey, Siti Numaisara binti Osman, Nur Fazli bin Muhammad Nur, and I'm Nur Adrina Fizana binti. Okay, as for introduction, I'm going to talk about the method that we use, which is image segmentation using also thresholding and image enhancement using histogram equalizations. Image thresholding segments an image into foregrounds and backgrounds by converting grayscale to binary based on the specific thresholds. Also, thresholding automatically determines the optimal threshold value to separate foregrounds and background, maximizing image contrast. Meanwhile, image enhancement using histogram equalization improves visual quality by redistributing pixel intensity, enhancing contrast and detail visibility. This technique aids in clearer image analysis, making it particularly effective for enhancing image before classifications or further processing. Our significance is the focusing on classifying bees and butterfly using also thresholdings and histogram equalizations. The implications is by enhancing accuracy and efficiency in inset identifications. The benefits by using this method is to reduce manual identification error, enabling analysis of large dataset, and it supports comprehensive studies of inset populations and dynamics. Our future direction is to explore advanced algorithms to further refine classification accuracy and expand application in image processing and machine learning.
Hi, Assalamualaikum. Now, I'm Nur Fazli. Now, we talk about the pre-processing methodology. This is the flow of our insect classification. First, we list the type of insects, category of image, or each type of insects. Then insert the dataset into the working directory. Uh, Next, image extraction and pre-processing, image adjustment using histogram equalization, segmentation using also thresholding, features extraction, combine image adjustment and segmentation. Next, develop segmentation with enhancements models. After that, we train the segmentation with the enhancements model. If the target training accuracy achieved, we save the developed model. If not, it will go to the train. Next is the test and the developed model. Evaluate prediction and accuracy. After that, the end of the pre-processing. Next is the image acquisition and the pre-processing. The project goal is identify the various insect species. We use the dataset, 15, 20 images and 5 test image. The image pre-processing step we use handling device format and size, resizing image, removing unwanted distortion, elimination background and noise. Next, the pre-processing objective. Enhance the image recognizability, ensure the consistent across the datasets, prepare image for the future preprocessing, and the outcome is the image ready for additional analysis and classification. This approach lays a solid foundation for a subsequent stage of your insect classification projects, ensuring that your dataset is clean, consistent, and optimized for the classification algorithm you'll be using. Next is image enhancement. The point of the image enhancement technique is to reduce the noise reduction. The smoothing we use the Gaussian filter and the contrast adjustment. The contrast adjustment adaptive histogram equalization endpoint and detail highlighting such as happening technique apply and image consistency to adjust the brightness and adjust the contrast. For overall objective, it will help us improve our image quality, ensure the image more consistency, and maintain the realistic appearance of the image. These enhancement techniques works together to prepare the insect image for more effective segmentation and classification in their later stage of this project. Now is segmentation. Segmentation identify areas where insects are present. The multi-step process is first we use image enhancement, And next, we use grayscale composition. The image enhancement detail improve the image quality, make the instead stand out more, so it will detect and more can be analyzed. And next, we apply filter, adjust the brightness, and also modify the contrast. This the grayscale conversion convert enhanced image to grayscale, reduce the image to the shades to the off gray, streamline subsequent processing. Overall goal is prepare the image for more effective insect area identification. This segmentation process create a foundation for accurately isolate the insect area in the image, which is crucial for subsequent classification stat. Next, we are also use the also thresholding. This technique This technique is purpose to minimize intra-class variations and determine the optimal threshold value. This use also use the pixel classification. Split pixel into two groups, background and foreground. The foreground is into the inside field area, and the output is the binary image creation. So for the binary image characteristic, is the white for the white pixel is the problem area, the admin insect, and the black pixel is the background. The benefit of using the auto thresholding is the highlight insect areas. The also facilitates accurate insect identification is in subsequent classification. This thresholding step effectively separate the insect from the background, creating a clear visual distinction that can be used in the final stage of your insect classification project. Last but not least, the classification. The nature is to simple and effective machine training model. The accessibility is easily accessed and used within the MATLAB's environment. The implementation require minimal tuning can be implemented with just a few lines of codes. The word principle find a key most similar instance, the nearest neighbor to the new unseen intents. Use label of nearest neighbors to make the prediction. The advantages is useful for the datasets with non-linear relationship. It effective when the underlying data distribution is unknown. So the consideration is sensitive to choice of k, sensitive to the distance metric is used. So the summary is highlight the main characteristics and the benefit of k and n that we are using it in MATLAB. So making them a potential suitable choice for your insect classification project.
Hi, so I'm going to show our original images for training and testing. So we decided to choose 20 images in total for bees and for butterflies. So we divide into 15 and 5. 15 for the training phase for bees and then another 5 for the testing phase. Same goes to the butterflies. Now we move to the feature extraction by using segmentation and enhancement technique, which is in the training phase. So our group chose to use process thresholding and also histogram equalization for the feature extraction. We go through our source code here. So firstly, we define the path to our training bee and butterfly images in our file, and then we we list out the file names for each of the images for the training. Next, we initialize the arrays to store features and labels for the training. Um, and then we move to the process the training and images. Here we use the for loop to train the images in as long as the images are still there, and then it will stop. So firstly, for the process of training, we read the image path, and then we pre-process the image where we convert to grayscale and apply the Oxus thresholding and enhancement here. So we use gray image and then convert to binary image. And then we also apply enhanced image. We use histogram equalization like in this way. And then we display our original and processed images for the training. for this first, and then move to the next part. We extract the features which are mean, standard deviation, and also entropy. So here we use the variable mean value, standard value, and also entropy value. And then we move to the append features and label one for this. So here we declare one is the value for this. And then that's all for the beginning part. So we move to the butterfly training images. We just use the same process, same for loop process. We train the classifier, which is we use k nearest neighbors classifier. So like in this code, we use the value as 3, and here we can adjust the parameters as needed. And then we save the train classifier and display a completion message. So here the message will be pop up in our command window in MATLAB. And lastly, we calculate the training accuracy. So as we got, the training accuracy is 73.33. And then as we can see here, this is some examples of output for this and multiply. So we just put 5 output here instead of 20. So this is the result of the we apply also thresholding and also enhancement here. So we can see the difference between the original image and also of the result. And then same goes to the butterfly. For the overall description of our training phase, so for the data processing, we load images of bees and butterflies, enhance each image, contrast, and apply process thresholding. For the picture extraction, we use mean, standard deviation, and also entropy from each image. For the model training, we create a feature matrix and label images, then split into training and testing sets, and then train the K and N classifier. Lastly, for the classification of new images, we evaluate the classifier's accuracy, then use it to classify new images based on extracted
I will
features.
explain about classification after applying segmentation and enhancement technique. For the testing process, we use the KNN classifier algorithm to test 5 new images for each insect, bees, and butterfly. The KNN algorithm works by finding the k most similar data points nearest neighbors to a new image and using their labels to make a prediction. The idea is that similar data points usually has similar labels. During training, the KNN algorithm stores the entire training dataset as a reference. The KNN classifier is useful for dataset with nonlinear relationships or unknown data distribution, while the choice of k and the distance metric can affect performance. KNN is popular for many classification tasks, including image classification, due to its simplicity and flexibility. We will go to the code for testing process. First, define paths and file name. The paths to the directories containing test image for bees and butterfly are defined. The file names for the test image are specified into separate arrays. Second, initialize arrays. Empty arrays are initialized to store features and actual label for the test image. Third, process B testing image. For each B image, the code extracts features and adds them to the X test array. The actual label 1 for bees is added to the Y test actual array. For process butterfly testing image, similarly, for each butterfly image, the code extracts features and adds them to the X test array. The actual label 2 for butterfly is added to the Y test actual array. Next, normalize test features. The features in the X test array are normalized to standardize the data. For calculate testing accuracy, the train classifier is used to predict labels for the test image. The accuracy of the prediction is calculated and displayed. For the visualize prediction for test image, for each test image, the code displays the image along with the actual and predicted labels. Separate loops are used for bee and butterfly image. Now we continue with feature extraction function. This function extracts features from an image. It converts the image to grayscale, enhance it using histogram equalization, and calculates three features: mean, standard deviation, and entropy. I will show you the output for the testing process for B. This is the output for testing process for B. The actual is B and the predicted is also B, and same as the second image. The last output for the testing process of B show the same as the previous one, which is the actual is B and the predicted is also B. So it shows us that the testing process of B is successful. Now we will go to the output for the testing process of butterfly. The output is for actual is butterfly but the predicted is B, same as the second image. For the last output for the testing process of butterfly, the actual is butterfly and the predicted is B. It shows us that the testing process cannot predict the image same as like the actual. So for overall result for the training and testing process is the training accuracy is 73.33% and for the testing accuracy is 50%. Description of testing process. For dataset preparation, the test dataset consists of 10 images, 5 bees and 5 butterflies, which are not used during training. For the feature extraction, load the test image and extract features such as mean, standard deviation, and entropy using the extract features function. Next, features normalization. Normalize the extracted features to ensure they are on the same scale. For classification and accuracy calculation, use the normalized features to predict the label with the trained KNN classifier. Calculate the testing accuracy as the percentage of correctly classified image. For visualization of prediction, display the original image along with their predicted label for qualitative evaluation. For the evaluation from the process is we use image processing and machine learning to help identify insect species with a set of 15 training and 5 test pictures. Making image clearer with steps like noise removal, smoothing, and adjusting light and dark part help us see better for our work. To find insect in pictures, we first turn the image black and white. Then, use a method called Oxus thresholding to make the insect stand out from the background. We sort the insect into groups using a tool called KNN classifier in MATLAB, which looks at the closest example to figure out what kind of insect it is. To make our insect sorting even better, we could use more pictures, keep the color information, and try out smarter ways of grouping with something called deep learning.
Hi, I'm Mid again, and now finally, the conclusion. This project showcased how to use MATLAB for classifying the bees and the butterfly image. By applying the thresholding for effective image segmentation, we extract the key feature like the area and the parameter to train the K, the nearest neighbor that using the L is KNN, the KNN classifier. Achieving 100% accuracy is distinguishing between the two. Additionally, the image enhancement through the histogram equalization improve the contrast, further refining the feature extraction process. Overall, the MATLAB tools facilitate the accurate object identification, highlight the importance of the pre-processing and the feature extraction in the classification task. This approach has potential application in biological research and other fields. And now there are some of the our reference for this project. You can see on the slide. Yes, that's all from us. Thank you, and I hope you enjoy. Bye bye.